Hi, Assalamualaikum everyone. Today we will do the theoretical how to convert the decimal number to the IEE 754, and there is the 6 main step that we need to follow to achieve the IEE 754. So the first thing is we need to determine the sign bit. How we want to determine is just look at the first bit of the number. If the number is 0, so it is the positive sign. But if the first sign bit is 1, it is negative sign. Next, we need to convert the decimal into the binary. For example, I have 9, and in the binary number it is 1001. If I have 0.57, if we need to convert to the binary, it will be 0.11 binary. Next, if we have the 9.75, we have 1001.11 in the binary. So actually we can do in the 9 divided by 2, we will get 1001 in the binary. So this is how we can get the binary number. So next, after we got the binary number, we will normalize, which is we need move the titik perpuluhan, which is if we move it 3 times, so we need to multiple to power of 3. So here we can see that this we call as a mantissa, and then this power we call as the exponent. So after we settle the normalized part, we will go to the calculate the bias exponents. So the bias for single precision is 1 to 7, which is this is the fixed number for the single precision. So we take this number, we will add with the 3 here, and then it will be 130. So 130 is in decimal, we need to convert it into the binary number. Same goes, we can got the binary, which is divide, you will get 1 in binary. Next, after you got this, we can go to the 5th step, which is the mantissa fraction field. So the mantissa fraction field is known to be 0011 1000, and the rest is 0. So after we settle those 5 steps, we can combine sign, exponent, and the mantissa. So the first bit is the sign, which is 0. We are moving forward is the exponent number, and then the moving forward is the mantissa. We just need to combine to get the IEE 754 number. I think that's all for the theoretically. Thank you.
Okay, so I will show the example how to convert the decimal number to IEEE. So for this example, we got 13.625. So first step, we must determine the sign bit. If a positive number is 0 and negative number is 1. So for this example, we got the positive number, so it is 0. And then for the second step, we must convert the magnitude, our number, to binary using the repeated division method. So for the 13 decimal to binary, we got 1101. And then for the fraction 0.625, we got the 101. And then we combine the number 13.625 decimal into binary, we got 1101.01.
Next step is normalizing the binary number. 1101.101 became 1.101101. We move forward 3 steps, so the exponent is 3, and the mantissa behind the decimal is 101.101. Next, compute the bias exponent. In single precision, we need to add 127 to the exponent, which will give us 130. Then we convert 130 to 8-bit binary, which will give us 100,00010. Next, assemble the fraction or mantissa, which the 8-bit binary we convert from 130, we add 0 to the number until the total of the number is 23 bits. Lastly, we combine all them together, which the first 1 bit is the sign, the next 8 bit is the exponent, and the last 23 bit is the fraction. And the result is like this.
Assalamualaikum. Okay, now as we already described the above, that we from the decimal to IEE 32 bit, now we're gonna to convert it back to the decimal. So for the to change it back, we need to split all the 32 bit into section. So the first number will be is the sign for whether it is a positive or a negative. The next 8 number will be the exponent, and then the rest of the number will be the mantissa. Then as we already split the bits, we are going to calculate the exponential. The 8 bit, we first transform the 8 bit into the decimal number, which is the 128, and 1 plus 2 equal 130. Then we subtract the number with the bias of 32 bit, which is 127, and we get 3 for this number. Then we gonna bring here for the formula to reconstruct the whole number. So for the mantissa, we gonna add the number 1, and the mantissa we only need the number from until the last number 1, and the rest of the zero will be ignored. So this is the number of the mantissa that we going to need, and this is the one from the mantissa to convert it. So we got this number. Then we gonna apply exponent, which is 2 the power of 3, which is 1001.101. Then we're going to convert it to the decimal, from binary to decimal. So we got 1 equal to 8, and this one is equal to 1. Then we got 9. Then this one is equal to 1 over 2, which is 0.5. And the third decimal is 1 over 8, is equal to 125.125. Then we adding the number together, 0.625. Then the whole number is 9.625. Since the sign is 0, the number will be the positive.
Okay, now we go for another example. First, we look at the sign. It say here is 0, so it's mean positive. And then we go to the next number, set of number, we go to here. First, we convert it from the binary form to the decimal form. We call this by exponential. After we get the 132, we minus it with 127. After that we get a 5. And then we go to this section. We only took this because the other back is 0, is useless. And then we bring it over here. We add 1 here, and then from the decimal point we go to 5 times. 1, 2, 3, 4, and 5. This is because we got the true SP is 5. And then after we get this, we convert it to the decimal form. After that we get the 37.5. That's all. Thank you.